Assalamualaikum warahmatullahi wabarakatuh. My name is Qais Naufal bin Zarisham from class RAS 1201I, and my student number is 2022460914. And the video I will be presenting today is about chemistry in food preservation. Uh, food preservation, what is it for? It is to prevent or slow down the growth of bacteria or molds so that food can be kept for a long time. Uh, Food preservation helps food stay longer wherever you may keep it, so that they don't go bad instantly, because we all know a lot of foods can go bad instantly. Not really instant, they can go bad really quick. Okay, so what are the examples? Today I'll be explaining three examples to you guys, which is salt on dry fish, sugar in jams, and vinegar in pickles. These three items can be found nearly everywhere, in every supermarket and in nearly every Malay household. How does food preservation works in these three examples I just gave? So sugar and salt, they work the same way, which is through forming a polar covalent bond with the water molecules inside the food they are present in. Both salt and sugar are polar. Okay, so polar. What is a what is a polar substance? For example, salt. Salt stands of uh, NaCl, where Na is positively charged and Cl is negatively charged. Just like the magnet, you see, where the magnet has a negative pole and a positive pole, same as salt, with a positive pole, which happens to be the Na, and the Cl presenting the negative pole, alright, being negatively charged. Mm. Sugar, or the ones we use at home, sucrose, has hydrogen and oxygen in them. So hydrogen, we all know, is positively charged, and oxygen is negatively charged. So there you see the poles, the negative and the positive. Water also consists of polar molecules, which happens to be hydrogen and oxygen. Again, the way they work is exactly like magnet, where the negative attract, where the opposites attract and the same repel. So when we pour salt in water, what happens is water breaks down the molecules, where the hydrogen attaches to the positively charged hydrogen attaches to the Cl minus, and the O minus attaches to the Na plus. So that is why salt can be that is why salt can be dissolved in water. Same goes to sugar. It works the same way. Now, how do they play a role in preserving fishes and jams? So we know fish came directly out of water, so it is very high in moisture. By pouring a lot of salt and rubbing it throughout the fish, the water uses every molecule to absorb this salt, right? So once every water has been used to latch on to the salt molecules, everything will be broken down. Alright, once everything is broken down, there is way more salt than water, to the extent where water is no longer found. So the fish goes dry. That way, there is no moisture in the fish to help bacteria grow, to help rapid up the activities of the bacteria. Same goes to sugars in jams. Once we mix the sugar in the juicy fruit blend of the jams, because every jams uses fruits, right? So once we pour the sugar on once we mix in a huge amount of sugar in the jam, uh, the juices, they try to dissolve the sugar, right? Latching onto the molecules, breaking down part by part, attaching the negative to the positive and the positive to the negative. And the same concept with the salt, until there is no water left in the jam and too much sugar. You know, that way there is no moisture in the fruit, so for the bacteria or molds to grow inside the jam. Therefore, the food can be kept longer, even if just stored in a dry jar. Uh, the bond that they form by breaking down the particle, by breaking down the atoms and latching onto the negatives and positive, is called the polar covalent bond. So that's why I say the polar covalent bond plays a big role in preserving food. Now moving on to our third and last example, which is the vinegar as preservative. Right, so it is a very common fact, a very common knowledge that vinegar is very acidic. That's why they taste and smell very weird. So once we have a very low pH level acid, such as vinegar. Uh, so wait, before that, acid the acid comes in a low pH level, which is below 7. All right. Uh, once once we add these acids, this vinegar that is very acidic to certain foods, or to foods, right? In this case, pickles. Once we put vinegar in the water, uh, they drop the pH level of water. Normally, water comes in at 7. The drinking water we drank comes at 7. Our pipe water usually comes at around 7. So once we put these acids in the water, they lower down the pH level of the water, right? It's just like negative in mathematics, right? When we have a huge negative number added on to a small positive number, what will happen is it will become a negative number 2. So that is how the pH level plays a role. All right, by lowering down the pH level of the water. Now, why does this low pH level, I've been repeating the same thing, right? How does it preserve water? Now, low pH level, as you can see, I've written there, equals to bad place. It is a bad place for bacteria to grow on. All right. So once our liquid is low in pH, bacteria won't grow, or maybe they will grow, but very often, so slightly, because of the conditions. So through this, the vegetables we pickle, all right, will be in a surrounding where it is hard for the bacteria or mold to grow. So yeah, that is how so to conclude this slide here, the vinegar, they preserve food by lowering pH level, so that the vegetables we dip in the substance is in a condition where the bacteria or molds cannot grow. So that's all from me. Thank you for watching, and I'll be looking forward to do more videos to teach you guys soon about more chemistry that happens in our daily life. Thank you.